All right, let's go over our multiple choice and AP tester trio. Okay, so here we had a question, and I was really actually kind of wondering if I had made a mistake when I put this down, so we'll talk about it here. So this was a problem where it actually was in our review problems in day one. So this is a continuation of that. So we had, first of all, I had to figure out what's X and what's Y. Okay. So we were, did it tell me there? Oh, well, we are interested in predicting the daily sales. So that's in a sense telling me that that's going to be my Y. Okay, so the daily sales are my Y. So looky here how then I labeled it. This is the Y bar for the mean of the Ys. Here's the S of Y for the standard deviation of the daily sales. So, and then I labeled the X's. Now, here's something I was wondering if I had a typo when I typed this up, but I went with it. So right here, it gave me r squared instead of r. And I don't know why I would have put that if that's not what it had said there on this particular lesson that I had gotten this from. So I went with it. And I also found that these answer choices were close enough together that depending on how you rounded and depending on if you square rooted that or not, it might affect what, even though just the rounding itself would affect your whether you get D or E. So in that case, I would really be looking at your process to see is your process correct, and I would follow your process and make sure you did the process correctly. So that process, of course, is first get the slope. And that slope is the variability in y over the variability in x times how well it's correlated. So I put that here with this 0.862 that I used because I square rooted that. And I did that times the complete. So I kept my decimals the whole way because these ended up being so close. So 7.442 over 182, there's the slope. So the slope, 0.03525, and I think that was the whole thing. So here I have that. So the predicting the daily sales would be that 0.03525 times the number of customers plus 13.35. Oh, how did I get 13.35? Well, let's take a look. I then went and I did y equals mx plus b. So y was my 38.778. M was what I had over here, 0.03525, and X was that X bar, that mean of X. I put all of that in and I got 13.35. So that is then how I got this equation of this sales prediction. So when I plugged in 800 for the number of customers, then I got 41.55. But seeing as how these are in thousands, then I multiplied by 1,000 and I got really close to this, just $5 off. Okay, and I think that was closer than anything I had come up with to get D. So I'm going to go with that. And again, those are so close. I'd have to look at your process, but if you followed that correct process, then I think you'd be good. All right, this is the residual plot, meaning, see, here is the LSRL, the least squares regression line, flat right there. Well, don't you see this? There's definitely a pattern in that residual plot, so a linear model is not appropriate. Okay, next. So here we had some different figures here. And so this says, so figure 1 is what's happening with this 0.107 in there. Okay, so this was the unusual point. So with this 0.107 in here, you can see, here's the rest of the data. But then this 0.107 kind of made that line all wonky. So the question is saying, hey, I believe it says if that point is removed. So let's look. Which of the following is true? Just is about what's the true. Okay. It has the largest residual? No. Look at these other guys. They have larger residuals. Is it influential? Heck yes. Look at how much it is changing that slope of the relationship. It is definitely changing that LSRL. So yes, it's influential. It's not an outlier in the X direction. It is farther out there. It is. Yeah. I was like, okay, yeah, it is an outlier. I mean, it does have high leverage. It's way far out there in the X directions out at 10, when the rest of the domain is from 2 to 6. Okay, so it's an outlier. So it is. The p-value of the linear regression changed. Has little changes if the points removed. No, the p-value is definitely going to get. It's going to represent a tighter, better linear fit, better linearity. And if you think about it, more linearity would mean a smaller p-value because you would have stronger evidence of that linear relationship. All right. And then the correlation is lower with the removal. Now the correlation increases. Okay, next, number 6. The t-distribution for inference about the mean is used in which of these situations? And so I had said this in the notes very clearly, and it is imperative that you understand why and when the t-distribution is used. It is used, point blank, if you do not have the standard deviation of the population. You only have the standard deviation of the sample. So that's what D says. So the rest of them are out. Doesn't matter. That is the reason. That's it. Okay? All right, now let's go over the AP Tester Trio real quickly here. So this was a neat problem. I liked these pictures. So you can see this yield versus the field that the plants were planted in. See, there's lots of overlap. This is not real. These are so varied. There's lots of variability happening in the amount of crop yield per acre. So I'm not really getting an indication, a strong indicator of which field is any better than the others. But when the variety of corn was used, changes in the varieties, we used different varieties. Wow. Do you remember that, so that is reducing that variability based on that variety. So that's really giving me an indicator of differences in the yield. For example, look at this one down here, very much lower than all of the others, okay? So there is a significant difference in the yield per acre due to the varieties of the corn, not the field. All right, number 2. So here this was mu1, let's see, mu1 was downtown, mu2 was at the airport. So you're doing downtown minus the airport, and I get a negative. If downtown minus the airport, and I get a negative, so downtown has to be lower. Downtown is lower. So that's what that's telling me. Downtown is lower than the airport, but the way they worded it was airport is higher. So either one of those, it's the same. So we're 95% confident that the average temperature at the airport is between 1.9 and 5.3 degrees warmer. Airport's warmer. Okay, and then our last one here. This is another transformation problem. This adding of 2,000 to all the pieces of data is a shift of $2,000 higher. So that will change the center, but it will not change the spread of the data. So the spreads are not changed. So what will happen to the standard deviation? It will remain the same. All right. Hope those went over well for you and that you understand what's going on there and all the review problems as well.